In question number 56, we are given the joint probability mass function of a random vector x, y. Also, we are given a random variable z, which is defined in terms of x and y. We are asked to find out the value of an expression involving the expectation of z and variance of z. Now, by having a look at the form of the given joint probability mass function, we can see that we can express it as the product of two functions in such a way that one function involves only x and the other function involves only y. Also, the support of this joint probability mass function is the Cartesian product of two sets in the two-dimensional Euclidean space. So the support of this random vector is actually a Cartesian product in the two-dimensional space. What does that mean? That means that x and y are independent random variables. Okay, if we can express the joint mass function as the product of two marginal mass functions, that means x and y are independent. That means the corresponding random variables are independent. That means x and y are independent random variables. It finally turns out that x is a binomial random variable having the parameters 10 and 1 by 4. Y also is a binomial random variable having the parameters 5 and 3 by 4. Now we can easily find out the expectation of x and expectation of y, also variance of x and variance of y. Now alpha is given to be expectation of z. So expectation of z can be found out using the expectation of x and expectation of y. Also beta is equal to variance of z. So variance of z can be found out using the variances of x and y. Okay, the covariance term, the term corresponding to covariance doesn't appear here because x and y are independent random variables. For independent variables, the covariance is equal to 0, so that term doesn't appear here. So we can easily calculate beta also. So alpha is equal to 45 by 4 and beta is equal to 45 by 16. Now we can easily calculate 8 alpha plus 48 beta, and it is equal to 225. So the answer is 225.